Now, the next section, 10-2, is on the areas of trapezoids, rhombi, and kites. Okay, keep in mind that the bases of a trapezoid are the two sides that are parallel. Okay, and also that the height of the trapezoid, or the altitude, is always perpendicular to the bases. Okay, now the equation in the book is that the area is 1/2 the height times the sum of the bases. Okay, personally, that's kind of a complicated formula to remember. And so I think of it as slightly different. I think about it in terms of the average of the bases. So if you think about how you find the average of two numbers, you add them together and divide by 2. Okay? And also if you average two lengths, you get the length that's right in the middle of them. Okay? So if I average the bases, I would have the length that's right between them. And I would get a rectangle, which the rectangle, and the base of the rectangle is the average of the bases, and the height is the height. Okay, so for me, it's easier to think about the average of the bases, b1 plus b2 over 2 times the height. Okay, which is very much like the first formula, except the 1/2 is inside the parentheses as opposed to outside the parentheses. It's easier for me to think about the average of the bases times the height. So I'll be using that one, but you can use either formula. Okay, so an example of finding the approximate area of Nevada. Okay, it's roughly a trapezoid shape. Okay, so the area is equal to the average of the bases. Now the bases are the two sides that are parallel. So it must be the 205 miles plus 511 divided by 2 is the average of the bases times the height perpendicular to those bases is 309. Okay? So 205 plus 511 divided by 2 is 358. Okay, the average of the bases times the height, 309. And what I get, 358 times 309 is 110,622 square miles. All right. The last idea is on the area of a rhombus or a kite. And the way you find the areas of a rhombus or a kite is the same. It's the product of the lengths of the diagonals divided by 2. Okay? So I have a rhombus drawn out down here. Sorry. Okay? One diagonal is 8. Okay, so the area is going to be 1/2 times 8 times the other diagonal of 14. Okay, so I do 8 times 14 divided by 2. And I get 56. Okay, I don't have a unit, so it's square units, but the area is 56. Okay, let's try a few more examples like that. Now in number 1, it's still a rhombus, but I'm not given the other part of the length. I know that this length right here is 3. So if you remember back when talking about rhombuses, that the diagonals bisect each other. They cut each other in half. So this length down here must also be 3. And if this length is 5, on the other side it must also be 5. Okay? So this diagonal is 6 feet. And this length is 10 feet. Okay, so again, it's half the product of the bases. And so 1/2 of 6 times 10 is 30. Okay, in summary, the area of a rectangle is base times height. The area of a parallelogram is also base times height. The area of a triangle is 1/2 the base times the height. The area of a trapezoid is 1/2 the height times the sum of the bases, or the way I think of it as the average of the bases times the height. The area of a rhombus is 1/2 the diagonals multiplied together, and the area of the kite is also 1/2 the diagonals multiplied together.